Okay, question number 29. This might take some time for me. Okay, let me start the timer. Right. So, on approaching a stationary object observer, a train sounds its horn and decelerates at a constant rate at time t. Okay, now you see it's a decelerating, which means what? Now, let us say this is my observer and this is my source. Okay, now as the source moves towards the observer, now the velocity is started to decrease. It's not increasing or it's not remaining constant. And to say decelerate the same rate, which diagram shows the variation with time of the frequency of the sound measured by the observer? What is the apparent frequency when the source is moving towards him and the source goes away from him? This is what has been asked. So towards it, now let us use the equation first. So because without equation you will not be able to understand this clearly. So we know that apparent frequency f dash is equal to v minus us, v by v minus us into f over here, where us is the velocity of the source. Now as the source velocity keeps on decreasing, let us say for example, if initial velocity when it is at this point, okay, is let us say for example 10 meter per second, okay, 10 meter per second. Now when it comes here, it could become 9 meter per second. Here it is 8 meter per second, and it is here it could be 7 meter per second, right? So when this becomes 9 meter per second, so initially at 10 meter per second, you will have some frequency f dash you will have. Let us say for example your f dash is some 370 hertz. Let me assume, I have not calculated anything. Let me assume it's 370 hertz. When it becomes 9 meters per second, that means when the source becomes 9 meter per second, the denominator actually, what will happen? It will increase over here, right? Because why does it increase? See, because this reduces, so v minus u, v is constant, right? Okay, so let me take for example, v is 340, and us initially is 10. So in the first case, let me write down clearly. So this is 340 minus 10 over here, which should be 340 divided by 330 into f. This was your f1 dash at this point. At f2 dash, what happens? It becomes 340 divided by 340 minus 9, right, at this point, which should now be equal to 340 divided by 331 into f. So if you compare between f2 dash and f1 dash, what's happening? This frequency is reducing as compared to this, because you see denominator is higher here and lower here, right? So therefore, since it is decelerating, this is what is happening, which means the next frequency when the source is coming towards the observer, the frequency is seen to be reducing, right? Frequency is seen to be reducing. So definitely option A is increasing and option C is also increasing. Both are incorrect. So it can be either B or D. Okay. Now why do we get this line? Why do we get this line over here? Because when the source and the observer are the same position, when the train engine is at this point, so they have the same frequency. So you get this line over here. Then after this, will it still reduce or will it increase like this? What does your this one say? Now let us see. Again, once again, we need to use our timetable, our formula, which tells you f dash is equal to v by v plus us, v plus us into f. Why is this plus us and here it is minus us? Reason is because here it was moving towards us. Okay, so in the first case, the train was here and the observer was here and the train was moving towards him, right? But so therefore the relative distance between these two was reducing over here. Okay, but when it crosses the observer and the train moves away from here, what's happening? Distance between the source and the observer is increasing, right? So as a result of it, you get the positive sign here. Right, now what happens once again? Now let us say for example, when it reaches the observer here at this point, let us say this, you get the value as something like 5 meter per second. 5 meter per second. Here it was 10, here it is 5 over here. Next moment, let us say here it becomes 4, next it becomes 3. In a similar analysis, what we do the same thing here, which should now be 340 divided by 340 plus, here it is 5, okay, at this site, which should now be equal to 340 divided by 345f. Okay, now this is, let us say, f3 dash. f4 dash will now be v divided by v plus us into f, which should be 340 divided by 340 plus 4 into f, which should be 340 divided by 344. Now you see denominator is increasing here. Okay, here it was here it is reducing here, it is increasing here. So as the source keeps on going away, the denominator keeps on increasing, which means what? So denominator keeps on decreasing, which means the frequency keeps on increasing, the apparent frequency keeps on increasing. Thus, here you see apparent frequency is decreasing. So, this is also not right. So, this is the correct answer. D is the correct answer. Okay. An excellent problem to understand Doppler effect. Okay. How does it work? Okay. It is not just substitute and use. So, practice it, and if you still do not get it, ask me in the comment section so that I can really help you out with this. Okay. Now, let us move on to the 30th question.